Yes, sir.
Okay, yeah. So we'll be just starting with Euclidean geometry. So the first thing that basically we're gonna be dealing with is quadrilaterals. So we'll be basically starting with quadrilaterals. Then one thing that you must actually know from this is that a quadrilateral is a closed. Can you all see? It's a closed figure. So when they ask you what is a quadrilateral, you must tell them a quadrilateral is a closed figure with 4 line segments. With four line segments as sides. So that's how we basically uh, define what is a quadrilateral. Then from here, are you all able to see?
Yes.
Okay. So when they say what is a quadrilateral, you say quadrilateral is a closed figure with 4 line segments as sides. Then one thing that you need to understand is that the following can be a quadrilateral. You can draw a quadrilateral which is like this. And then you can label it as A, B, C, D. So that is a quadrilateral. Or if not only this one, you can also have, please draw them because they will help you. Can actually have something like that. That's also a quadrilateral. You can label this as P, Q, P, Q, and then here it's R, S. So either one of these two, it's what we call quadrilaterals. So there are many of those. And then now let's go into the deeper part because I'm just showing you the basics because I will be introducing you to theorems that has to do with Euclidean geometry. So here on number 2, we are dealing with different types of quadrilaterals. Now, are you able to see? Minent, are you able to see?
Yes, sir.
Okay. Naldo. So now we are dealing with different types of quadrilaterals. So when we speak about different types of quadrilaterals, number 1, You can find a kite. You can find a kite. So if they ask you what is a quadrilateral, you'll tell them that I told you a quadrilateral is a closed figure with 4 line segments, right, as sides. So that's how basically we define it. And then now let's deal with a kite, because you'll actually come across this. So when you speak about a kite, it's a quadrilateral. So this one is quadrilateral. Quadrilateral is a quadrilateral with 2 pairs of adjacent sides equal. With 2 pairs of adjacent sides equal. So when they say what is a kite, we'll just tell them that the kite is a quadrilateral with 2 pairs of adjacent sides being equal. So now let's draw a kite. So as we are drawing a kite, the kite is like this. You all know a kite, it's like this. That is going to be our kite. Then we label that as A, B, C, then D. So since this is a kite and it's a quadrilateral with 2 pairs of adjacent sides being equal, it means to say this side is going to be equals to this side. And then this side, AB, is going to be equals to BC, because that is a kite. So either you draw it like that, or you rather draw it like this. It's still going to be a kite. Still going to be a kite if you draw it like that. Still going to be a kite. And then we say that is A. Then that is B, C, D. Then this side is close to that one. Then this side is close to that one. So this is a kite. Now you understand what is a kite. So if they ask you what is a kite at school, now we are not going to be confused, because I've actually showed you that that is a kite. And one thing that you need to understand is that A, B, C, D, from these drawings, we know that A, B, C, D, it's a kite, is a kite, because it's a kite because what? AD is close to DC. Because AD is close to DC from the diagram. Ne? And what? And AB is close to BC. And AB it's equals to BC. So that's why we say this is what? This is a kite. Are you all writing?
Yes, sir.
Yeah. So those are some of the things that you must actually know with regards to with regards to what? With regards to the basics of a kite. Any question? Any question? Okay,
No.
let's now proceed. So that is a kite. Ne? And then secondly, we are having what we call a trapezium. We are now having what we call a trapezium. Why is it using this? We are having what we call a trapezium. So when we speak about the trapezium, what are we speaking about? So a trapezium is a quadrilateral with one pair of opposite sides parallel. Is a what? Is a quadrilateral trapezium. It's a quadrilateral with one pair of opposite sides parallel. With one pair of opposite sides parallel. So if they ask you at school what is a trapezium, you must not be confused. Tell them that a trapezium is a quadrilateral with one pair of opposite sides parallel. So that is a, a trapezium. Then one thing that you need to understand, if the non-parallel sides are equal, 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 then the trapezium is called then the trapezium is called then the trapezium is called what? It's called an isosceles trapezium. It's called an isosceles trapezium. Please make sure that you write it properly. Isosceles trapezium. So the thing is that some of your teachers, they won't teach you the basics that I'm teaching you. That's why normally I take time to write these notes, because I understand that as they're going to teach you geometry, they're not gonna teach you this. Any question?
No question.
Yeah. So when they say what is a trapezium, you must tell them that it's a quadrilateral with one pair of opposite sides parallel. So that's a trapezium. Ne? And then
Yes.
can I continue?
Yes, Mr.
Okay, let's continue. Then this is a trapezium. If you didn't know, this is how we draw a trapezium. Then let's say this is A, B, then that will be CD. So with regards to a trapezium, you will always have these two lines being parallel to each other. Do you all see? Then
Yes, Mr.
we'll say A, B, A, B, C, D is a trapezium. It's a trapezium. ABCD is a trapezium because the reason why we are saying it's a trapezium is because of what? It's because of AB is parallel to CD. Now, as I'm introducing this topic, it's gonna be a long topic, but it needs you to know these basics. That's why I'm teaching you these basics. Ne? Any question?
Yes, Mr. No question, sir.
Okay. So since there are no question, now let's proceed. Then if you're having something like this, so with regards to this again, so that's, let's say it's PQRS. It's PRS. So since this is it's a trapezium because we know that we're gonna have parallel lines here. The other thing that you must not forget is that these two sides are gonna be equal in length. This side is equal to that side. And then this one, I'm gonna say P, Q, R, S, PQRS is an isosceles trapezium. It's an isosceles it's an isosceles trapezium because it's an isosceles trapezium because PS is parallel to QR. Because PS is parallel to what? To QR. And then end what? and PQ
is equals to SR.
equals to SR. Sure. We are also taking this from this statement. So you must not be confused.
Yes,
All these basics, you must know them by heart. The trapezium is a quadrilateral with one pair of opposite sides parallel. And then that blue statement is very important. Why I say if the non-parallel sides are equal, then the trapezium is called an isosceles trapezium. So that's why I've showed you that this first diagram normally say that it's going to be a what? A trapezium, because ABCD is a trapezium because AB is parallel to CD. But with regards to the second diagram, which is this one, being represented by PQRS, I'm going to say PQRS is an isosceles trapezium. So you highlight this or you underline it, it's an isosceles trapezium. Why do we say it's an isosceles trapezium? Because PS is parallel to QR and then PQ is equal to SR. So those are some of the basics that you need to understand. Any question?
no question, Miss.
We're done with the kite, we're done with the trapezium. Go to a parallelogram. These are the basics because the theorems that are associated with Euclidean geometry. But the reason I don't want to start with theorems, you'll struggle if you don't know what is a parallelogram. So that's why I normally start with the information, and then we'll go to the theorems. Parallelogram. Who can tell me what is a parallelogram? So this is a what? A quadrilateral. I hope all of you are writing, ne?
Yes, Miss.
Yeah. Sure, okay, let's. Naldo, are you writing? It's a quadrilateral.
Yes, sir.
Sure. Minent, are you writing?
Yes, sir.
Okay. It's a quadrilateral with both pairs of opposite sides. Of opposite sides. Both pairs of opposite sides. So it's a quadrilateral with both pairs of opposite sides parallel. So this is what we mean when we speak about the parallelogram. Then the parallelogram is like this. So that's going to be A, B, C, D. Then this side is parallel to this side. And then this side is going to be parallel to that one. So you must know this by heart. All this, what I'm saying, you must know it. So we're going to say A, B, C, D, it's a parallelogram. A, B, C, D is a parallelogram. ABC is a parallelogram since what? Since AB is parallel to DC, AB is parallel to DC, and AC and the AC, it's parallel to what? BD. So that's why we are saying this is a parallelogram. Any question?
No questions, sir.
Sure. Minant, any question?
No.
Naldo, any question?
No, sir.
Okay, sure. Then since there are no question, we are done. We are done with a kite. We are done with the trapezium. We are done with the parallelogram, which was number 3. Then now we go to number 4. Number 4, speaking about the rectangle. So when you speak about a rectangle is a parallelogram. Rectangle is a parallelogram with all the angles 90 degrees. With all the angles 90 degrees. So we are drawing a rectangle. It means to say a rectangle, we all know that that's going to be like this. That is going to be our rectangle right there. So let's call it A, B, C, D. Then this is going to be 90 degrees right here, 90 degrees right there, 90 degrees here, 90 degrees right there, right? And then since this is a rectangle, it means here we're going to have both pairs of sides being parallel, like this. As well as here, we're going to have this being parallel to that. So the reason why I was saying it's a rectangle, the reason why we are saying it's a rectangle is because of the following. I'm going to say ABCD is a rectangle because ABCD is a rectangle because ABCD is a rectangle because ABCD is a parallelogram because ABCD
Sir,
is a parallelogram. Yes.
you wrote because twice.
Oh, thanks. ABCD is a rectangle because ABCD is a parallelogram the parallelogram and angle A It's equals to angle B. It's equals to angle C. It's equals to angle D. Which all in case all of this, they're all equals to what? 90 degrees. That's all we are saying. It's a rectangle. Any question?
No question, miss.
Okay. We are left with the remaining two. I taught you a kite today. I taught you a trapezium. I taught you what? A parallelogram. I taught you a rectangle. So we are left with two, of which we're going to cover them in our next session, which will be a rhombus and then followed by a square. And then after that, now I'm going to introduce theorems that are in geometry. So the first theorem that will be basically dealing its opposite and angles of a parallelogram. Theorem number one of Euclidean geometry says that opposite sides of a parallelogram are equal. Then in an exam, they will want you to prove that the opposite sides of a parallelogram are equal. You're going to use the concept and the method that I will have taught you in making sure that you understand Euclidean geometry, because this is a topic that carries a lot of marks. The way I'm teaching it, teachers that might not teach it like this, and you will be required to calculate certain angles. I'm just going to show you a way in which you will come across these questions in an exam. And then if you don't know how to prove, then it's going to be a problem, it's going to be a challenge. Ne? But if you
Yes, sir.
are going to understand all the theorems, all the laws that I will have taught you, then that will be very, very, very. Ne? Any question?
Yes, sir.
No.
No question, miss.
Please, let's practice. And what you can do, make sure that you practice all the information that I gave you, because your teachers, they're not going to give you the notes that I gave you. These notes, if you are playing with them, then I don't know what's going to happen, because you're more fortunate, because myself, as your teacher, I'm teaching you everything. So if you're fortunate enough being taught by myself, then there are high chances for you to get a distinction, because I'm preparing you in advance. So some of your peers, some of your classmates, they don't know this information that I'm teaching you. So you on the other side, when you're practicing, it gives you a better chance to be ahead of your peers, and you will understand it more often, because I will have taught you everything. But if you are that kind of a student, I give you information, then you relax, then I don't know what's going to happen. Ne?
Yes, miss.
Any question?
No question, sir.
So, Keleto, Minentle, any question?
No, sir.
Okay, sure. Do you understand Minentle?
Yes, sir.
Okay. Naldo, any question?
No, sir.
You understand?
Yes, sir.
Okay, sure. Then it means to say, since you all don't have questions, you are done for today. We'll end up here. And then,
Oh, sir, I have a
Thank you.
question.
yeah,
So why don't you put the lines that bisect, like the two lines that bisect?
it's a good question. You mean on my, what do you call? Let me go to it on the diagram. On my parallelogram. Or on the rectangle.
On the kite, sir, because there are two lines that bisect and then forms 90 degrees.
Let me go to my kite. It can be on a kite, but I think I get your point. It must be on a rectangle. Because when we speak about the line that bisects, is the line that cuts into two equal parts. So, Keleto, in minute, this is what Naldo is trying to say. Let me show you. You're not going to be wrong. You see this kite? I can decide to do like this. Let me show you. I can
So
decide.
wait, are we on the kite or the rectangle?
I'm speaking about the rectangle. Naldo said on the kite, so I'm just correcting him. So you're not going to be wrong. because you understand one of the properties of a rectangle is that both pairs of opposite sides they're equal in length, and then the diagonals bisect each other at right angles. You know, at right angles is 90 degrees. So when we say the diagonals get those two lines which are going simultaneously vertically, simultaneously intersecting. And then when we are saying the diagonals, they bisect each other. Bisect means it cuts into two equal parts. So I can just consider drawing them like that. But the reason why I didn't want to draw them now, I just want you to actually familiarize yourself with knowing what is a parallelogram, what is a rhombus, and then the lines that are basically bisecting. You'll see it when we are now proving those theorems. That's when actually I will go into greater detail of me showing you how do you draw those diagonal lines, because as we'll be drawing those diagonal lines now, though we'll be taking it into consideration, or we are now drawing our construction, because for us to prove, we must draw a construction of which that construction that we're going to basically draw, it will make us to consider that as a diagonal line, as I will be proving on my theorem. So the purpose of today's session, I just wanted you to know the basics of what is a rectangle, what is a kite, what is a quadrilateral, etc., etc. Ne? Did I answer you, Naldo? Naldo? Any question, guys?
Go.
Okay, sure.
No question, miss.
Okay, sure. If there are no questions, then it means to say we are done for today. Make sure that you practice, and yeah, practice makes perfect. Sharp, sharp, guys.
You say
Yes, Naldo, you are saying?
nothing, say nothing, say.
Okay, any question, guys?
No question, sir.
Okay, yeah. Then we are done for today. Sharp, sharp. Keep on practicing.